In this section, we'll learn about function notation, which specifically talks about how to find a function value given x and how to find an x given a function value. So function notation is simply a way of writing input and output. Mathematically, there's really not going to be a change. So before, we used to write a function as y equals. Now we're just taking this y equals and substituting in this fx symbol for it. So a function instead is going to look like f parentheses x equals, and then this might be like 2x plus 7 or something. Before, an ordered pair used to be written x comma y. X is still our input, so we're still going to have x, but instead of putting y in this spot, we're going to put f parentheses x. And the way that that is read, it literally means function of x. It doesn't mean to multiply. That's kind of huge. Normally when you have something stuck to parentheses, it means that you're multiplying. It's just a notation. It's just a way of reading function of x. That's how it's read. So just like x is our most common variable, f is typically your most common function. But then you could also have function as a g, just because it comes after f, and then h. Anytime you see something kind of in this format with the parentheses and the x inside, it really just means function of x, function of x, function of x. So f of 7 would mean to substitute 7 into the function everywhere you see an x. The big thing with functions is if you can substitute, you can be successful. So here on this first problem we have our function of x equals 3x minus 15. And they're asking us to evaluate the function when x equals negative 3. So what that's really asking you to do is, we know the input because we know x, and we're trying to find the output. So when the input is negative 3, what's the output? So to do that, everywhere I see an x, I'm going to put in a negative 3. So this says the function when x is negative 3, that's basically what this says right here, it's going to be equal to 3 times whatever, or 3 times negative 3, and then minus 15. So if you keep going, you would get the function at the value negative 3 is equal to 3 times negative 3 is negative 9, and then negative 9 minus 15, you'd make that plus negative, it would be negative 24. And so this is our final answer right here. And what that means is that when x is negative 3, you can kind of see, here's the x, here's the x. So when x is negative 3, the output, or the function, I'll say the output, is negative 24. And so then for this next one, I'm evaluating the function h of x equals negative 7x, and I'm going to replace x with 7. So the function at the value 7 would be negative 7 times 7, so the function at the value 7 equals negative 49. And if you look at both of these, we're not trying to isolate f or h. This is, because it's not really a variable, it's just a notation. So this says the function when the input's negative 3 is negative 24. The function when the input is 7 is negative 49. So we're done. Pause the video, try this example right here. Your final answer should be in that format. Press play when you're ready to check. So in this example, everywhere you see an x, you're replacing it with negative 8 because that's your input. So the function when the input is negative 8 is negative 4. Again, we don't try to isolate f, it's just a notation. A lot of people ask, why can't you write your answer like this? The function of x equals negative 4. So on this slide, we're actually doing the exact opposite of what we did on the previous problems. Here, you are given the output, you're given f of x, and now you're trying to find the input. So here's my function, fx equals 2x minus 10. I'm just going to rewrite it so I have some room. And what they're giving us is fx. So this says everywhere you see the fx symbol, which I see it right here, saying take it away and put a 6 in its place. So I'm going to do that. So I'm going to change fx to 6. I just substituted. And I just bring down the rest, the 2x minus 10. So it's really important that the whole symbol, f parentheses x, that whole thing right there is equivalent to 6. So that 6 takes the place of the whole symbol. It's just basic substitution. And now we're going to isolate x by using reverse PEMDAS. So first I would add 10 to both sides. So I'd have 16 equals 2x. And then divide both sides by 2, and I get 8. So that means that the input of 8 is the input that you would need to produce the output of 6. Pause the video, try this example right here, press play when you're ready to check your answer. So on this example here, this says everywhere you see the FX symbol, which I do, replace it with 16. So I have 16 equals negative 2x plus 4, isolate x using reverse PEMDAS, and then x is negative 6. And so this is the input, negative 6, that would cause an output of 16.